All right, day 2 of earthquakes. Page 144, Seismic Waves. There's going to be enough notes, and we're out of room, so we're going to go ahead and switch to the back. Use my little paperweight, AVID rocks there. Seismic Waves. Capital S-E-I-S-M-I-C. Waves, capital W-A-V-E-S. Pencil. Remember that tectonic plates move very slowly. Sometimes rocks move along easily with the plates, but they also can jam up against a plate or between two plates. Over time, stress builds up within the rock as the plates strain against each other. Okay, so plates, P-L-A-T-E-S, strain, S-T-R-A-I-N, V-S period, versus is against, so strain versus or against each, E-A-C-H, other, O-T-H-E-R. Let's see, so plates strain against each other, stress builds up. Stress, S-T-R-E-S-S, builds, B-U-I-L-D-S, up, U-P. Eventually, the stress becomes so great that rocks break. The plates shudder and jolt into a new position. This causes an earthquake. Okay, stress builds up. So a break, B-R-E-A-K, / jolt, J-O-L-T, arrow, earthquake, E-A-R-T-H-Q-U-A-K-E. The released energy travels in waves in all directions, including up to the surface. These waves are called seismic waves. They cause the motion that is felt as an earthquake. Okay, so that's the name of this section, and we had a vocabulary term on the front. Seismic wave. Wave of energy, spreads all directions, detects... Oops, not seismograph. Okay, stop there. All right, body waves. And then, okay, I'm seeing a black heading, body waves, so I'm looking for other big black headings, surface waves. Okay, so we're going to go ahead and make a new title here. Body waves, capital B-O-D-Y, waves, capital W-A-V-E-S. Seismic waves that travel through Earth's interior are called body waves. Okay, so interior, I-N-T-E-R-I-O-R, so that's inside the Earth. That would be down deep in the crust or even down in the mantle and further down. There are two kinds of body waves, P waves and S waves. I bet they're going to give us a definition. P waves, or primary waves, are an example of longitudinal waves. All right, let's figure this out. Okay, so let's go right here, skip a line. P waves, P-waves, W-A-V-E-S. It says primary, P-R-I-M-A-R-Y. Primary is the same thing as first or initial. Primary is like the beginning. First, zoop, beginning, B-E-G-I-N, double the N, I-N-G, and turn that into a semicolon. Okay, and now longitudinal, L-O-N-G-I-T-U-D-I-N-A-L, longitudinal, longitudinal. Okay, longitudinal. Let's look at this picture over here. Longitudinal waves. There's a slinky. Each coil moves back and forth as the wave travels through the spring. Like P waves, this is a longitudinal wave. So imagine that that slinky is the crust of the Earth. And then imagine these kids are pushing and pulling the slinky back and forth. You can see that little spot where the slinky's kind of like squished together, and you could see it stretching and moving this way, and then he pushes it and it stretches and goes back towards her, and then she pushes it as he's pulling and it's going back and forth. Those are longitudinal waves, kind of like a compression moving in and out. So longitudinal is kind of like a slinky, S-L-I-N-K-Y. It's almost like stretching, S-T-R-E-T-C, and compressing, C-O-M-P-R-E-S-S-I-N-G. P-R-E-S-S. So sometimes it stretches, and other parts it compresses, like a slinky. All right, let's go on to here. Rocks move back and forth in the same direction the wave travels. Okay, so the pieces of the slinky move back and forth in the same way that the wave travels. P waves are the fastest kind of seismic wave, traveling at about 6 kilometers per second through rock. Oh, so if they're the fastest, that means they arrive first, making them the primary waves. Okay, so that's important. They are primary, they are first, they're in the beginning because they are the fastest. F-A-S-T-E-S-T. During an earthquake, the first jolt or thud you feel is the arrival of the P waves. The P waves push and pull on rock along their path. As P waves reach the surface, the ground cracks and crumples. Okay, so it can cause a crack, C-R-A-C-K, or a crumple, C-R-U-M-P-L-E. The second type of body wave is the S wave, or secondary wave. Second, number 2, happens second, secondary wave. Oh, okay, S wave, W-A-V-E. Second, S-E-C-O-N-D-A-R-Y. Okay, and we don't need to say it's not first because it's second, secondary. S waves are transverse waves, okay. T-R-A-N-S V-E-R-S-E, transverse, transverse. Okay, a transverse wave is like a big wobbly thing like that. See the girl and the boy with the rope and transverse wave? If she lifts it up and down, and he lifts it up and down, it will flip and wobble up and down in a transverse wave. So now come up here to longitudinal wiggle slinky, erase that. That's going to confuse us. We don't want to accidentally think that longitudinal waves look like this. So longitudinal equals slinky. Let's go ahead and draw some lines that are far apart, and then they get closer together, and then they get far apart again. Whoops. And I'm going to draw one more over here so it looks like they're close. So, right, they are spread out, but they kind of squish together. So the motion is in and out. And then it can go both directions. So it can go in, and the wave can travel that way. Then it can go out, and the wave can travel back the other way, like a slinky. Transverse is going to be up and down. Okay. Rocks move up and down or side to side at right angles to the direction of the wave travels. So what they're saying is the wave is traveling that way, but the rock is wobbling at a 90-degree angle compared to that. Basically like a jump rope. So let's go ahead and say J-U-M-P-R-O-P-E, jump rope. S waves are slower than P waves. They are called secondary waves because they arrive after the P waves in an earthquake. Okay, so these are slower, obviously. If P waves are the fastest, nothing can be faster, so they must be slower than P waves. The rope moves up and down as the wave travels through it. Like S waves, this is a transverse wave. Okay, when S waves hit, you might feel a strong side-to-side motion. Okay, so what's really going on is there is the wobbling up and down as the wave travels from the center of the earth up to the surface. What else? P waves can travel through solids and liquids, including Earth's liquid outer core. Oh. S waves, however, can only travel through solid rock. Oh, interesting. So like a shock wave can travel through liquid, But the wobbling like this rope cannot go through a liquid because the liquids are not connected like that. So up here by P waves, let's say rock, R-O-C-K, plus liquid, L-I-Q-U-I-D. S wave, let's say rock only. And in front of that, let's put solid, S-O-L-I-D. Rock, R-O-C-K, only, O-N-L-Y. Up here in front of rock, solid, S-O-L-I-D. So P waves can travel through solid rock and liquid, but S waves can travel through solid rock only. Okay, surface waves. That's a new heading. Capital S-U-R-F-A-C-E, surface waves, W-A-V-E-S. Other waves called surface waves travel only across Earth's surface. One type of surface wave is the L wave, or love wave. Okay, interesting. L-wave, and it's called the, let's see, that was primary, that was secondary, this is love, L-O-V-E. Okay, why is it called that? It is named for the British scientist who discovered it. Oh, okay, the guy's name was Love. Like maybe his name was Edward Love or something like that. I don't know what his name was, but his name was Love. L waves travel the slowest. Oh, okay. So that's why it's capitalized with a capital L, because it was named after that guy. And they are the slowest, S-L-O-W-E-S-T. So if L waves are the slowest, P waves are the fastest, S waves are in between. They arrive just after the P waves and S waves. Surface waves do not travel as far from an earthquake's origin as body waves. Okay, so they don't, D-O-N apostrophe T, travel, T-R-A-V-E-L, as, A-F, far, F-A-R. And we don't have to do the rest because we can infer they don't travel as far as S waves and P waves, or the body waves. They cause a rolling motion on the surface that can cause great damage to structures. Okay, rolling, R-O-L-L-I-N-G, motion, M-O-T-I-O-N, arrow, damage, D-A-M-A-G-E, exclamation point, so that we know it's a lot of damage. L waves often are the most destructive because they cause a lot of damage. Although each type of wave differs in velocity, all seismic waves travel very fast, several kilometers per second. As Californians know, they can cause huge damage. Scientists and engineers have learned all sorts of ways to prepare for earthquakes, but there is no way to stop them altogether. Okay, let's look. P waves are the first to arrive. We know that. At the surface, they are longitudinal waves. Okay, longitudinal, like a slinky moving in and out. S waves come next. They are transverse waves. Okay, they're secondary. That's second. That's next. Transverse, they're moving up and down like someone holding a jump rope and whipping it up and down, high and low, high and low. L waves are a type of surface wave. These are typically very destructive. L waves are surface waves. They cause a lot of damage. All right, compare the surface movements caused by P waves and S waves. Compare P and S. Compare P and S. Okay. P waves and S waves are both body waves. However, zoop, P waves can travel through solid rock and liquid, zoop, while S waves only travel through solid rock, Also, zoop, P waves are the fastest, zoop, so they arrive at the surface first, S waves are a little bit slower, zoop, so they are secondary, or arrive later, Finally, zoop, P waves are longitudinal, so they move in and out like a slinky, stretching and compressing to crack and crumple the crust. S waves are transverse, zoop, meaning they move up and down or side to side like a jump rope being whipped by two students. All right. That is everything for this part. Good job persevering with a growth mindset. Roar Wildcats!